Okay, just a few more questions on solving equations for exercise 14a types of questions. So the first one, remember we're in radians, so solve tan of x plus pi on 3 equals root 3 for x lying between negative pi and pi. Now remember we have to adjust our domain. So at the moment it's between negative pi and pi for x. However, we're looking at x plus pi on 3. So we need to add pi on 3 to each of those endpoints. So that will be, so this is just my domain to start with. So 1 pi plus pi plus pi on 3 is 1 1/3 pi, which is 4 pi on 3. And negative 1 plus 1/3 is negative 2/3, so it's negative 2 pi on 3. So that will be the domain in which I'm working. So again, we solve using our 3 steps. Tan is positive, so we say tan is positive in quadrants 1 and 3. And then we need our acute angle x plus pi on 3. So we say tan of what is root 3, and we know that's tan 60 degrees. However, we're working on radians now, which is pi on 3. So remember that was 60 degrees. Okay, and then we write out our solutions. So we're going to draw our solutions first. We're in quadrants 1 and quadrant 3. And we need to make sure that our solutions are lying between 4 pi on 3 and negative 2 pi on 3. So we have to start from 0 and go all the way round to 4 pi on 3. Now 4 pi on 3 is pi plus pi on 3. So let's have a look. We need to go all the way to there. So our first solution is pi on 3, and that does fit in the range. So x plus pi on 3 equals pi on 3 is my first solution. So I'm allowed to go from 0 to 4 pi on 3, which is pi plus pi on 3. So here's my first solution, pi on 3. Yes, that's in. Then I've got pi plus pi on 3, which is 4 pi on 3. And then I have to stop there and I have to come back this way. So if this fraction, if this angle here is pi on 3, then this is 2 pi on 3, but we're going in the negative direction. So that angle there is negative 2 pi on 3, and that's where I hit my next solution. It is on the boundary, so that solution is included as well. Okay, now these are the solutions for x plus pi on 3. So I need to subtract pi on 3 from each of these. So I've got pi on 3 minus pi on 3 is 0. 4 pi on 3 minus pi on 3 is pi. And negative 2 pi on 3 minus pi on 3 is negative 3 pi on 3, which is negative pi. I'll just show how I did that down here. It was pi on 3 minus pi on 3. Then it was 4 pi on 3 minus pi on 3, which is 3 pi on 3, which is 1. And then it was negative 2 pi on 3 minus pi on 3. So that's negative 2/3 minus 1/3. That's negative 1 or negative 1 pi. Okay, so they're my solutions. Okay, now my next type of question is to solve this. Now, I've got everything over the left-hand side equals 0. The first thing you need to do is to factorize. So sine of x is a common factor, so I take that out. Okay, so now I need to solve two equations. The first one, so just checking that that's correct, and it is. My first one is that sine x equals 0, or my second equation is that sine x minus cos x equals 0. So sine x equals 0, remember we're solving for 0 to 2 pi, is solved. We solve that by sketching, where our amplitude is 1 and negative 1. Instead of writing 360 degrees, it's 2 pi. This is pi, and that's 0. So where does sine of x equal 0? Well, it's at those 3 points, which is 0, pi, and 2 pi. Now, we need to solve this. Sine of x minus cos x equals 0 first. We start by taking the cos x to the right-hand side. And remember, when we're solving sine x equals cos x, we need to divide through by cos x. And the reason is that that will give us tan x. So we're not actually losing or eliminating any functions here. We're just really changing the way this looks. Okay, so dividing both sides by cos x gives me tan x equals 1. So I need to solve that equation, tan x equals 1, within the domain from 0 to 2 pi. So again, my 3 steps, we can see tan is positive in quadrants 1 and 3. Then we need our acute angle x. Now tan of what is 1? We know that's tan of 45 degrees, or tan of pi on 4. And then we sketch our solutions in quadrant 1 and 3. And then we list our solutions. So my solutions will be, we're going all the way from 0 to 2 pi. It'll be pi on 4 for quadrant 1, and quadrant 3 will be pi plus pi on 4, or, which is, 180 plus. So it's 180 plus, which is pi plus. So my two solutions are pi on 4 and 1 1/4, which is 5 pi on 4. So these are all my solutions, so I need to list them all. Okay? So you might want to underline them or write the 5 of those solutions again. So often we'll then go, so x is 0, pi on 4, pi, maybe in order if you want, 5 pi on 4 and 2 pi. With my next equation, it appears that we cannot factorize this the way it is. However, we do know that sine squared theta plus cos squared theta equals 1. That's one of the identities that we looked at last week. So if I rearrange my sine squared theta and make it the subject, I know that sine squared theta is 1 minus cos squared theta. So now what I can do, I'm going to replace this sine squared theta with 1 minus cos squared theta. So I've got 2 bracket 1 minus cos squared theta plus cos theta equals 1. So now I may have a chance of solving this, because once I expand this, I'm hoping it's going to be a nice quadratic that I can factorize. So here, because I've got sine squared theta and cos theta, I can't factorize, I can't do anything. So I know that relationship, the Pythagorean identity, that sine squared theta plus cos squared theta is 1. So I use that to rearrange and to substitute for sine squared. Now I'm going to expand. So I've got 2 times 1 is 2. Minus 2 cos squared theta, so I've expanded that, plus cos theta equals 1. Now what I'd like is for the cos squared theta to be positive, so I'm going to take everything over to the right, and I'm going to get 2 cos squared theta, so that's going over, minus cos theta. Now the 1 is already there, plus 1, and this 2 is coming over. So everything's over to the right. So I've got 2 cos squared theta minus cos theta minus 1 equals 0. So I'm hoping that we can factorize this. So just pretending that the cos theta is an x, let's see. Minus 2x plus, yes, that looks okay. So I've got 2 cos theta plus 1, sorry, and just cos theta minus 1. Let's just check that this is going to work. 2 cos squared theta minus 2 cos theta plus cos theta minus 1. Yes, that gives me that. So now I've got my two different solutions that I need to look at here. So I've got that 2 cos theta plus 1 is 0, so therefore cos theta is -1/2. So I need to solve that. And over here I've got that cos theta minus 1 is 0, so cos theta is 1. And I need to solve that. Going from 0 to 2 pi, so just following the same steps again. So when you've got something with a squared, it's going to be a quadratic, okay? So where is cos negative? So using our steps, so cos is negative in quadrants 2 and 3. Then you need your acute angle theta. So cos of what? So this is what we're solving, these two. Cos of what is 1/2. That's cos 60. Now 60 degrees is pi on 3. And you can just draw out your solutions in quadrants 2 and 3 and write up your solutions. So our first one, well, if that's a third, this will be 2/3. So that's 2 pi on 3. And this is pi plus pi on 3. And you can think of this one as pi minus pi on 3. So this is 2 pi on 3 and 1 plus a third, that's 1 1/3, which is 4 pi on 3. Then your other solution, remember if you're solving cos or sine equals 0, 1 or -1, you need to draw the cos curve. So where does cos theta equal 0? Here we've got 2 pi. This is pi, so that must be pi on 2 and 3 pi on 2. So these are our solutions. We have 4 solutions. Okay? 1, 2, 3, 4. So we want to write them all out again. So we've got pi on 2, 2 pi on 3, 4 pi on 3, and 3 pi on 2. The order in which you write them doesn't really matter. Okay? I try and write them from smallest to largest. Another type of question. Now it appears, if it just looks like this, that we can't solve it, but why don't we rewrite what sec theta is, and we know it's 1 over cos theta. So we want to remove the cos theta from that denominator, so we're going to multiply both sides, or multiply through by cos theta. Remember, you're allowed to do the same thing to both sides, so I'm going to multiply the left and the right by cos theta. That will give me 4 cos squared theta, because that's how I write cos theta times cos theta equals 1 over cos theta times cos theta. Now when I multiply the left and the right hand side by cos theta, I get cos squared here, but these two cos thetas cancel. So what I've really got here is that 4 cos squared theta is 1. Now we need to rewrite that as cos squared theta is a quarter, but we don't solve for cos squared. We want to solve for cos theta. Now remembering, when taking the square root, it's plus or minus the square root. So the square root of a quarter is a half, because the square root of 4 is 2. So now I'm solving 2 equations. That cos theta is, I'm in 4 quadrants. So cos theta is positive or cos theta is negative. So we're in all 4 quadrants. Remember, our first step is the quadrants. And then we want our acute angle theta. Now, cos of what is a half? Now we're again solving from 0 to 2 pi here. Okay. So cos of what is a half? That's cos of 60. 60 is pi on 3. And then you can just draw up your little diagram and put in all your solutions. Okay. So we've got quadrant 1 is pi on 3, then we've got pi minus pi on 3, and then we've got pi plus pi on 3, and we've got 2 pi minus pi on 3. And just evaluating those all out, 1 minus a third is 2/3, 1 plus a third is 1 1/3, which is 4 pi on 3, and 2 minus a third is 1 2/3, which is 5 pi on 3. Okay. Now this is a type of question that we have not done yet. It is the same. You've seen things like sine of 2x or sine of x plus something or x minus something, but this is sine of x on 2. So what's happened to the x this time? It appears to be halved. So we have to halve the endpoints of the domain. So 0 divided by 2 is 0 and 2 pi divided by 2 is pi. So really we're only wanting solutions in quadrants 1 and 2. Okay, so actually what I might do, I'm going to, oh no, I'll just leave it, it's fine. So let's have a look. So remember the same steps. So the quadrants, sine is positive in quadrants 1 and 2. So actually it's not really going to affect us. And the acute angle, x on 2, so sine of what is root 3 on 2? Well, it's not sine 30, it's actually sine 60. Now 60 is pi on 3. So therefore, my solutions for x on 2, again, we just draw up where we are. We're in quadrants 1 and 2. So that x on 2 is, this solution here is pi on 3. And this other one is pi minus pi on 3. So x on 2 is pi on 3 and 2 pi on 3, because it's 1 minus a third pi. So to get x on its own, because we are solving for x, you need to multiply these all by 2. So I end up with pi on 3 times 2, which is 2 pi on 3. We multiply this by 2 and I get 4 pi on 3, because I'm just multiplying both of these by 2. And those solutions do fit in my domain from 0 to 2 pi. So you'll see in the next one it's going to be a little bit different, okay? Because I'm just lucky here that sine was positive in 1 and 2, and quadrants 1 and 2, and my domain was restricted to 1 and 2, so it really didn't knock out any of my solutions at the beginning. But let's have a look at this next one. So the next one is a similar thing. And what I might actually do, I might change this question and make it negative pi here. Okay, just for something a bit different. So solving of x on 2 equals negative 1 on root 3 from negative pi to pi. Now, from negative 2 pi to pi. So if x lies between negative 2 pi and pi, then x on 2, I have to halve everything, divide everything by 2, and I'll get from actually negative pi to pi, because I have to divide these all by 2. So that's my new domain. So let's just start again. So tan is, it's negative. So it's negative in quadrants 2 and 4. And my acute angle, x on 2 is, now tan of what is 1 on root 3? So it's tan of 30, and 30 is 180 over 6, or pi on 6. So again, we're going to draw our solutions in their quadrants. That's pi on 6 there, and pi on 6 here, quadrants 2 and 4. And now I have to write down what my solutions are. So x on 2 is, I'm going from 0 to pi, so that's all the way from there to there, and find any solutions. And my only solution is, well, if that's pi on 6, then this must be 5 pi on 6. So it's pi minus pi on 6, which is 5 pi on 6. And then I have to stop here. I've got to come back this way. So quadrant 4 here is just negative pi on 6 there. Okay. So I've got that x on 2 is 5 pi on 6 and negative pi on 6. And now for my solutions, I'm trying to find x. You just have to make sure you check this whole domain. Now to find x, the inverse operation of dividing by 2 is to multiply by 2. So I multiply these both by 2, and I get 10 pi on 6 and negative 2 pi on 6. And you can simplify that if you want to, 5 pi on 3 and negative pi on 3. And they're your two solutions. Okay, now for, I think this is, yes it is, it's the last question. And it's just similar to something we did before, but I'm not sure if this one's going to give us an exact answer. So let's see how we go. So 2 sec squared theta equals tan theta. Now we have to see if it's going to be a quadratic, but at the moment there's no relationship between the sec squared theta and the tan theta. However, we do know with our little thing, it's that 1 plus tan squared theta equals sec squared theta. So what we're going to do is replace this sec squared theta with 1 plus tan squared theta. So I've got 2 bracket 1 plus tan squared theta equals 5 tan theta. Now we do have a quadratic, but we need to take it all to the left hand side and put equal to 0. However, we do need to expand first. So 2 times 1 is 2 plus 2 tan squared theta. So I've expanded, and I'm going to bring this one over. Minus 5 tan theta equals 0. So just putting my squared term first, and then my ordinary term, and then my constant. Now, remember this, just think of it as if we just let x be tan theta, it's like we're solving 2x squared minus 5x plus 2. So let's see if we can, oh no, it may work. This might work. So I've got minus 4x minus 1x, that's minus 5x. And that times that is positive 2, and that times that is 2x squared. I think it's going to work. So what we've got is 2 tan theta minus 1, bracket tan theta minus 2. So let's have a look. 2 tan squared theta minus 4 tan theta minus 1 tan theta, and that's correct, and then plus 2, so that works. So therefore we're solving 2 tan theta minus 1 is 0, or tan theta minus 2 is 0. So this gives me that tan theta is a half, and this one is that tan theta is 2. Now there is no exact solutions for these, so this one's a little bit different. So you need to get your calculator out, and you need to work out, we've got to do the same method, but we're not going to have exact values. So again, we say that tan is positive in quadrants 1 and 3, and over here it'll be the same thing. I've got quadrants 1 and 3, but we need to find our acute angle. So my acute angle theta, you'll need your calculator for that, and you'll be doing tan to the minus 1/2, and over here you'll need your acute angle theta as well, and you'll be doing tan to the minus 1/2, because tan of what is 2, and here tan of what is 1/2. Here, because it's not an exact value, and we are not working in degrees, so you need to change your calculator, and it cannot be in degrees mode. So I don't know if you can see this, but wait, I've got a bit of light. Sorry, 1 minute. Some light here. I must change my mode, so I can't do it in degrees mode, because I'm going to end up with something like, if I do shift tan of 1/2, I end up with 26 degrees, and that's not, remember we're working radians, so that's incorrect. I need to go into radians mode, so I press my degrees button until I get radians mode, because remember we're working in radians, and I go shift tan of 1/2, and I get 0.4636. So I'm going to write that down. So my acute angle here is not 29 degrees 36 minutes, it's 0.4636. Okay, so remember I'm looking for quadrants 1 and 3, and quadrant 1 is just where it appears, okay, and quadrant 3 is down there. So in quadrant 1 I've got 0.4636, and in quadrant 3, remember it's 180 plus, but we don't use 180, it's pi plus 0.4636. So I'm just going to go dot dot dot. So what I do, I keep this answer here, 0.4636, sorry, just trying to shine some light here, and I need to add pi to it. So there it is, add pi, because it's pi plus that answer, and I get 3.6052. So I've got, my two answers are 0.4636 and 3.6052. And look, you can just give those answers, for example, to 2 decimal places would be enough. We're going to do the same over here. We've got that tan theta equals 2. So on our calculator, you cannot just do you can't do it in degrees because we're working in radians. So we go second function tan of 2, and we get 1.107. So I've got acute angle is 1.107. So my two solutions, again, I'm in quadrants 1 and 3. So quadrant 1 is 1.107, and quadrant 3 is pi plus 1.107. So 1.107 and pi plus that. So just keeping that answer in your calculator, add pi to it. So it's 4.28. 4.24, I'm going to go 87. 4.2487. Now what we would do is, you can just maybe give it to 2 decimal places. So 1.11 and 4.25 to 2 dp, for example. Okay. Question is to solve, sorry that's not written very clearly, tan x equals √2 minus 1 for 0 less than or equal to x less than or equal to 2 pi. So remember, this √2 minus 1 is just a number. So tan of some angle is √2 minus 1. Now because we're working in radians, again, the calculator has to be in radians. So just making sure that that calculator is in radians mode. We are in radians mode, and we're doing tan of what? So shift tan, and you need to put a bracket, square root of 2 minus 1, close bracket. So tan of what angle gives me √2 minus 1? Because tan of theta is √2 minus 1. So we go shift tan, brackets, √2 minus 1 equals. Now that gives me my acute angle, and it's 0.39, let's say 3927, just to round it. The other thing is, √2 minus 1, if you just look at that on your calculator and what it's equivalent to see what quadrants we're in. So square root of 2 minus 1 is actually, so the actual value for root 2 minus 1 is 0.414. So it's positive, in other words. So tan of something is positive. So that gives us our quadrants. So tan is positive in quadrants 1 and 3. Okay? So my acute angle X is that. So I draw quadrant 1 and I draw quadrant 3. And the values of that is that 0.3927. Remember, this is in radians. Remember, 1 radian is about 57 degrees. So don't be worried that you see such small values there like that. So quadrant 1, so my two solutions are, so my quadrant 1 solution is just what you see, 0.3927. And my quadrant 3 solution, remember, it's pi plus 0.3927. So just keep that answer in your calculator and add pi to it. And so my two solutions are 0.3927 and 3.5558. So that is, I know I'm giving a lot of decimal places there, but you just see what the question requires. The end of the examples.